Hello everyone. Welcome to Applications Manager's free training series on application performance monitoring. So let's jump into today's agenda. So we are going to cover overall four parts, and in the first part, we will discuss on how to utilize APDEX scores to gain insights into application performance and identify the areas for improvement. In the second part, we will explore tracking code flows and pinpointing the problematic elements in your application code via distributed tracing. In the third part, we will visualize the dependencies in your application architecture with automated service maps. Lastly, we will be looking at how to gain deep insights into front-end performance by analyzing the real user behavior patterns to resolve potential user issues impacting issues in real time. Before discussing the topics on the agenda, so let's start with why application performance monitoring is required. So just imagine a user who is accessing an e-commerce website and trying to purchase from the online store. After adding the required items to the cart, they are trying to attempt to place the order. So now at the time of placing the order on the payment portal page, they encounter issues like the portal is taking more time to load or getting redirected to a different page or showing some error codes, etc. So this operation could lead us to the loss of potential customers from accessing the application and led to the loss of business as well. And for the developers who are working in this web application will be unsure of the root cause. So in this scenario, the demand for using the application has increased, which also led us to the complexity of its development. So hence it is necessary for the developers who are working in the application to make sure that the website is bug free and can handle the load in the application database to ensure providing a better service to their users. Now here are some of the contemporary trends in the application monitoring. So let's discuss one by one. The first one is cloud native applications. Nowadays, simply large enterprises have adapted to move many of their applications into the cloud. So, where cloud native applications are scalable, flexible, and also efficient, and use small independent building blocks like microservices, containerization, commonly Docker and Kubernetes. So, developers and the operation team work closely together using DevOps practices. So further, for faster and more reliable software delivery, such as monitoring this application is essential, which helps in analyzing how each part of the application is working and trying to fix any issues in the handling of lot of users. And the second one is artificial intelligence for IT operations in the context of application performance monitoring. So AI and machine learning in the recent times have been used to enhance and automate IT operations through anomaly detection for identifying unusual deviations, automate the IT task and predictive analysis for the potential future using the historical data and optimize the resource allocation for scaling based on the real-time performance data. So on the third one is user-centric monitoring. User-centric monitoring shifts the focus from system-centric metrics to the actual end user's experience. So when interacting with an application, no, so users' experience is measured by examining their journey from the moment they access the application to the complex completion and identifying user-centric metrics such as page load times, the response time, and the overall responsiveness of the application. So which will also, with the help of helping the developer to prioritize important improvements and enhances the user satisfaction as well. So which is the third one. And the fourth one is the application observability. Application observability, including application performance monitoring, will help in gaining insights into the application behavior and also health of the application, which is achieved through monitoring applications, transactions, test logs, execution time, and identifying the bottlenecks, errors, and inefficiencies in the code. The last one is full stack performance monitoring. The goal of full stack performance monitoring is to identify and address the performance issues across the entire application stack from the front end user interface to the back end server infrastructure. So, by monitoring various layers of the stack, including the application code, server response times, and the database queries, this is achieved by collecting the real time data on various performance metrics like response time and error rates. So by adopting these latest trends which have discussed, So organizations can gain more insights into the performance of their application in real time by enabling them to proactively identify and also resolve any potential issues before they impact the end users. So this will ensure that for maintaining reliability and availability for the responsiveness of modern applications. So let's explore the benefits of modern versus traditional approaches in building an application. So in the traditional approach, the applications were hosted on on-premise or a single data center, experiencing high downtime and limited availability, leading to a potential performance issues during the traffic periods. However, leveraging cloud computing and containerization for better availability and utilizing features like load balancing, redundancy, automatic failure, and global distribution has minimized the downtime, enabling continuous deployment without affecting the user experience. And further, the scaling of traditional applications involved purchasing additional hardware and substantial investment in the infrastructure. Also, high maintenance costs due to the need for physical hardware updates and repairs are required. So, with the cloud-based solutions, reducing the upfront cost, allowing efficient resource utilization, horizontal scaling of resource based on the demand, automation, and containerization contributed to the operational cost savings as well. So, the third one is the global content delivery. So, content delivery may be constrained to a specific location or a data center where the users in the different regions might experience latency and slower performance. So, using content delivery networks and the edge computing will ensure a faster and more reliable delivery globally. So, further, cloud services offer distributed content across multiple servers globally, so reducing the latency of the users worldwide. And this improves the user experience and ensures consistent performance worldwide. The last one is operational efficiency. So managing and maintaining the traditional applications will involve manual process for their deployment, scaling, and maintenance within limited flexibility, agilely the responding to the changes of the business requirements. So now DevOps practices such as infrastructure as continuation, continuous deployment pipeline, and container orchestration tools will automate the process, enhancing operational efficiency. So the microservices architecture enhances agility and scalability for evolving applications as well. So updates can be rolled out seamlessly without any downtime, and resources can be managed automatically. In adopting approach to building application will offer advantages such as availability, cost reduction, global content delivery, and efficiency. Now, compared to the traditional methods, cloud computing, automation, and modern architectural principles are key factors that will contribute to these benefits. So it enables businesses to stay competitive and responsive to the changing demands. The modern approach benefits such as scalability, reliability, global contribute to higher availability when compared to the traditional approach. So far, we have this application performance monitoring is necessary in the applications manager. So let's see further. The performance monitoring feature is called here is the APM Insight. APM Insight will give you an understanding on your way how your application behaves for your end users who are accessing it by a complete end-to-end transaction monitoring across your entire web application, which will help you to avoid any performance issues. So you can analyze the root cause of the problems much faster by performing the first level of troubleshooting. Further, the supported technologies are APM Insight are Java, Node.js, .NET, Node.js, .NET Core, Microsoft .NET, and PHP, Ruby Rails, and Python. Okay, so here these are some of the factors that will play a crucial role in determining the performance of our application. So let's see each one of these factors in detail. The first one is the response time. When user in application, The request is sent from the application layer through the and the network layers. Further, it will hit the application server, and this request to the end users as well. The response time is taken for a transaction to be processed, so which includes the time taken from initiating the request to receiving the final response. The query response time is taken by the database query to retrieve and return the data, or the speed which the database queries are executed. Slow queries can significantly impact the overall application performance. The application performance response time is the time taken by the application to respond to the users or requests, user inputs or requests. So, which will include the processing time, the network latency, and any other delays. So, the application code, we know that bugs in the application code can lead to unexpected behavior. So, crashes or performance degradation and and handling can impact the overall performance, and the frequent exceptions might be indicate issues that need more. When an error occurs, the stack trace provides information about the sequence or the function calls leading up to the errors. So analyzing the stack define source of issue. Okay. The third one is memory. Monitoring the application memory consumption is crucial. So high memory usage can lead to the performance issues and even crashes. So if the application it's allocated memory crash or became unresponsive. So this occurs when the program doesn't release properly, leading to the gradual increase in memory usage over time. The last one is the database. So database queries that will take long time to be executed can impact entire application's responsiveness. And here, optimizing these queries is very essential, and the number of calls made to the database can impact the performance. So reducing any unnecessary or duplicative database calls can improve the overall performance, overall speed of the application. So hence monitoring and optimizing these factors are essential for maintaining good application performance. Various monitoring solutions can help you to identify and also address performance issues in each of the areas. Also, regular performance testings and tuning are very essential for ensuring an application to run. Further, a website performance can be impacted by several key factors. So these include schedule maintenance and data center or web server errors, which are often unavoidable but should be well communicated. So bugs in the code can lead to instability, while high traffic spikes can overwhelm resources. So hacking attempts pose security and availability risk, and failure to renew SSL certificates also can result in trust issues and access disruptions. So here, proactive monitoring and timely updates are essential to minimize downtime and ensure a smooth user experience. Here, the application performance monitoring insight is a tool that uses agents for monitoring the application. The initial step will involve deploying an agent onto the servers where the applications are running. These agents are responsible for gathering the performance data and transmitting it into the applications manager for analysis. Now, the agent within the application server utilizes a method bytecode instrumentation technology in order to track the individual users' transaction as they navigate through the application stack. Then it will send this transaction data to applications manager at a fixed time interval, and the approach will enable detailed monitoring of the transaction performance, facilitating an identification of the bottlenecks or any performance issues. The tool will offer code level visibility, allowing monitoring of slow database queries and their performance by capturing the real time user interactions within the application. So users can configure any alerts and notifications based on the predefined thresholds for that specific metrics impact the application performance. So when the application performance reaches its threshold, the tool will send an alert to the IT team. So this alert system will help the developers and the IT team pinpoint the areas that require improvement in performance, such as application code, database related issues, and page load times. So this proactive approach helps addresses the issues promptly and minimize the downtime in the long run. And here, these are some of the key performance indicators in APM Insight. The first one is the APDEX score. APDEX is a numerical measure of user satisfaction with the performance of the application's response time. The second one is the response time. It measures the average time taken for an application to respond to a user's request for the transaction across application. So lowering the response time in general is more desirable for the users to have good user experience. The third one is request. So which is the total number of requests made to the application within a specific time frame and helps to decide the overall workload and the usage of the application. The fourth one is data throughput. So it indicates the amount of data in bytes are transferred or processed in and out of the network that taken a request by the application during the monitoring period. So which will also help in understanding the application's data handling capability as well. The fifth one is exceptions. So the exceptions will track the number of exception errors or the failures that occurs during the cycle of transactions in the chosen duration of the processing the request. So such as server errors, timeouts, and other issues that affect the application's normal operations. So now let's see how to utilize AppDex scores to gain insight into the application performance and identify the areas for improvement. The AppDex score is categorized based on the application responsiveness. So the first one is satisfaction. So this category represents the highest level of user experience, where the application's response time in between the satisfied threshold and the excellent threshold. The users in this category are generally satisfied with this application performance. And the second one is the tolerance. So the tolerance category indicates the application's response time in between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance, but may not be entirely satisfied as under the satisfied category. So the last one is a frustration. So this category represents the lowest level of user experience, where the application's response time is below the tolerating threshold. So users in this category are more likely to be frustrated with the application performance as it does not meet their expectation. So checking the application performance with the AppDex score. So this application performance index or the AppDex score is a standard metric that used to measure the user satisfaction and the application response time. The AppDex scale ranges from 0 to 1, where 1 being the best and representing the excellent user satisfaction. So based on the total samples that are collected, the AppDex score is calculated as the sum of satisfied plus half of the tolerating count over the total samples that are collected during the specific transaction. So here some of the advantages of monitoring the application's performance with AppDex score. So let us see one by one. The first one is a user-centric performance measurement to understand the application behavior. So which will also help you to understand how each application performance directly impacts the user experience and enable you to prioritize the improvement. The second one is easy understanding of complex performance data with a common performance metric will help you to simplify the complexity of the data into a single and easily understandable metric. So by providing a clear and standardized way to assess the application performance. The third one is you can benchmark and compare the performance of the different level of applications, which will allow you to identify the high performance applications leading to a consistent improvement across your IT environment. The fourth one is proactive issue identification and prioritizing of optimization. So when the performance falls below the acceptable level, the AppDex code will help you to identify the critical transaction with low scores. Highlight the areas for the code optimization will also helps, and alerts are triggered by enabling quick issue identification and improving the key transaction that impact user satisfaction. So at last, the historical APDEX trend data will allow you to analyze a performance pattern over time, helping in understanding the performance trends and identifying improvements for ensuring a consistent positive user experience. Now moving forward, let's see how to track code flows and pinpoint problematic elements in your application code via distributed tracing. So in the microservices architecture, it is necessary to monitor the transactions made between two or more application services. With the distributed tracing feature, you can track the transaction made between two or more applications. So just to understand how tracking is done in the distributed tracing, first, an API request is made by the application to another application. The APM insight will add an HTTP header containing the metadata that is required to track the request. So if the APM insight is enabled in the other application, it will process the HTTP header and return the tracing information. So it is called but to its caller via the response headers. So in the other application, it turn calls another service. The header propagation will continue and the trace and it will trace all the parts that are taken by the original application across the distributed system. So using this data, we can monitor the start time and that is when the transaction was initiated, and the response time taken for the transaction to respond within the application, and the name of the transaction and the application. So by clicking on the expand view as seen in the screenshot mentioned in the slide, uh, you can have the application name, you can view the method calls and the code blocks that has taken significant amount of time to complete the each request, and this will enable you to monitor the calls made between two applications and narrow down the problem. So here we have the auto scaling in APM inside. So auto scaling is an automated way of managing the resources of your application in the APM inside feature. So imagine you have a website or an application running on a cloud environment. So whenever the application automatically scales up due to a higher user interaction on the site, and to handle the extra traffic, a new instance will be added. However, when these applications are scaled down due to fewer user transactions or interactions, this newly added instance will be unused and it is still retained. So this will lead you to the license being consumed by the unused instances. So which will result in the new instances not being added for monitoring. So hence, with the help of this auto scale mode in the APM Insight, you can overcome this scenario by automatically unmanaging or deleting unused instances in your cloud environment. Let's see the need for eliminating the issues in problematic code. As you are aware, the state trace represents the movement of application during the execution of a program. So when the Java application throws an exception, the stack trace gets logged in within it. So by enabling the stack trace providing by APM Insights, the developers can pinpoint the exact line of the code and the sequence of the function calls leading to the root cause of the issue. Here, by gaining deeper visibility into the Java based application performance using the context based monitoring, you can enable context based monitoring for your Java application. So this will allow the tool to track and trace individual user transactions, capturing data on how each registration transaction flows through your application server. Here, let's say your application server has three Java applications running on it. By default, transactions for all the applications coming from the same application server are shown collectively under the web transaction tab on the APM Insight. So in the image, as you can see, Tomcat application is the application monitor name, and the JPEG store sample and the sample web page are the context running on the same application server. The transaction of these three Java apps are listed in the web transaction tab. Now, With the context-based monitoring, you can monitor the performance of all the individual applications, so running in the same application server separately, so which will help you to analyze the application's performance. So this means by enabling context-based monitoring, the transaction of the JPEG store, the sample web page shown here, and the store sample can be viewed separately as well in each in the same UI. So further, we have introduced the RUM analytics feature in APM Insight to provide real-time insights into the user interactions. So which will allow businesses to monitor and optimize application performance even more effectively. So by tracking key metrics such as response time, page views, JavaScript errors, and geographic performance trends, it helps identify slow transactions, errors, and performance bottlenecks across different devices and locations. This data enables organizations to proactively optimize their application behavior, ensuring a seamless user experience and improve the overall performance. Also, we have the application dashboard in Applications Manager that provides a comprehensive view of application performance and the user experience by combining the data from the APM Insight and the real user monitoring. So this integration allows for a unified summary of both backend and the user level performance. So helping IT teams monitor the key metrics such as APDEX score, user sessions, failed requests, slow transactions, and error reports as well. So additionally, this dashboard provides geographical insights to help you analyze the performance trends across different regions as well. So by using this dashboard, organizations can quickly diagnose issues and optimize their applications to ensure a seamless user experience. Next, we have the revamped Ad Monitor page for APM Insight to simplify the onboarding process and further making it more flexible and have a good user experience. Now, with this structured step-by-step flow, you can effortlessly configure the APM Insight monitoring setup. Added to these features, we introduced the instance level alarm metric feature that allows users to configure alarms using more granular set of performance indicator at the instance level as well. So this enhancement provides a precise monitoring by enabling users to select a specific monitor and associate thresholds with key attributes. So by setting alarms for these instance level metrics, businesses can proactively track performance deviations, identify potential issues, and optimize application behaviors more effectively. So here we are moving on to the visualize the dependencies in your application architecture with the automated service map. What is a service map here? So it will provide you with a complete overview of application infrastructure along with a connection to the other dependent resources. So the main purpose of a service map is to identify the status of application and its related instances, monitor the key metrics like response time throughput and the status of the connection. Further, and it will detect and troubleshoot any application problems before the customers are impacted, and also to identify the number of failed request counts as well. So there are three types of service map. One is the map view, and the other one is the table view, another one is the graph view. So with the help of these three views, we can have the unified viewing experience of the service maps. So here is a map view. So it will provide a way of analyzing the topological view of the application along with these instances represented in the central node. And we can directly hover to any one of the instances to identify the health of the specific instance. So going to the last side, let's discuss gaining real-time insights into front-end performance by analyzing the real user behavior and resolving the user impacts issues very instantly. The first we have here is the synthetic monitoring. So where you can analyze the performance from an end user's perspective through the synthetic transaction. So this involves assessing the website's performance as experienced by a typical user, so which helps identify issues that might otherwise that goes unnoticed. So you can test the performance of critical users parts on your website by recording complex workflows using the web transaction recorder. For example, consider the process of navigating an e-commerce website, logging in, searching for a product, adding it to the cart, proceeding to the product payment gateway, and logging out. So synthetic monitoring allows you to record such a complex workflow to keep an eye on the important transaction happening to your website. So if an error occurs in the payment gateway phase, it helps you to identify these issues before the end users account them. So can we can check the specific areas and fix the specific issue. So further, you can have the have dynamically track the website's availability and performance from an end user's location. So using end user monitoring agents. So one of the main advantages in the ability to monitor the availability and the performance of your website from the user's locations is very helpful. So this ensures your website meets its service level and business level objectives. So by verifying whether these SLAs are being met, so you can gain a clear view of your service level agreements in order to prevent any other issues. So let's see how applications manages a real browser monitoring enhances synthetic transaction monitoring. So this feature also known as real browser monitoring in Applications Manager, so which will launch as an actual browser like Firefox from multiple geographical locations, tracks how website elements load from those locations, and simulates the user experience. So first, it will simulate business critical processes using Selenium based scripting. So every action performed during recording, such as hovering or clicking on the element, is saved in a Selenium script. So then Applications Manager opens a real browser such as Chrome or Firefox. So by default, the Firefox will be bundled and replace the recorded transaction to identify any errors during the playback. So once done, all performance metrics are published on the monitoring dashboards. Also, it will allow you to take screenshots during playback if any error occurs. So the main advantage of synthetic monitoring is that it enables testing from different locations, whether enterprise branches or actual user locations. Facilitate monitoring across multiple locations, we use end user monitoring agents. For example, if you are hosting an event at your office and have created a registration form, it is important that employees from all the branch offices can register without any issues. So to test this critical workflow, you can use applications managers, real browser monitoring. First, you need to install a end user monitoring agent in all of your branch offices. Next, you can record the process of filling out and submitting the registration form from your main office. The same transaction will be executed in your branch offices with the help of these agents. So we will send the data back to the applications manager. So this setup allows you to verify the workflow operates smoothly and error free across all locations. Also, the end user monitoring agent provides enhanced visibility to the user experience and helps identify potential performance issues. So, these agents can be installed in the branch office across its different cities or directly on the end user systems. All that is required is a secure HTTPS connection between the agent and the applications manager hosted server. So let's move on to the use cases for synthetic transaction monitoring. So what are the some of the scenarios where your business might be a benefit from the synthetic transaction monitoring? First, you can use it to compare your website performance within your competitors by setting up a benchmark scenarios. So you can also track how your application performance over time and compare the company's performance on top competitors within a specific historical time frame or geographical region. This approach helps you to develop a strategic outlook and maintain a competitive edge in the market. Next, with the help of the synthetic transaction monitoring, you can test new features. Since testing is crucial during the early stage of application development, synthetic monitoring provides baselines and thresholds that help identify potential obstacles in the real time. Further, you can assess the performance of third-party applications. Today's websites increasingly rely on third-party features such as customer reviews, web analytics, social networking, SEO add-ons, and video contents as well. So, if any of these elements fails, it can negatively impact your website. So, synthetic transaction monitoring helps you to keep track of these third-party applications, alerting you in case of any performance degradation or downtime issues. So this essential for managing service level issues and service level agreements and holding third party vendors accountable. So by monitoring the steps involved in transactions and the page load times of each step, so you can evaluate the complete performance of the third party applications as well. So if a certain element transaction time is slower than usual, you can confirm that the third party application may be underperforming. And lastly, synthetic monitoring also provides direct feedback on performance issues, allowing your team to identify the root cause, engage the right experts, and resolve problems before they impact the users. So now, what is real user monitoring? So previously, we discussed on the real browser monitoring. So now let's see what is real user monitoring. So real user monitoring involves capturing users' interactions within the website's real time. So it helps you to analyze how your end users sense your website. As businesses expand digitally and globally, your websites can be accessed from various devices and locations. So it is crucial to provide a consistent user experience across all geographies and devices. However, user experience can be affected by factors like network latency, operational issues, double retrieving resources, and slow internet services providers. So, what works well in one browser might not work in the other, and this where the real user monitoring provides valuable values. So it allows you to understand why your website performance poorly in specific regions, identify any overlooked issues affecting page load times, and determine why users abandon pages. So this information helps you to optimize your website performance. Unlike synthetic monitoring, which tests the websites before the users interact with it, real user monitoring actually uh, records the complete transaction of the live transaction of the user's interaction. So to understand why a real user monitoring is essential, we first need to consider the drawbacks of synthetic transaction monitoring. So one major limitation of synthetic transaction monitoring is that it does not always align with reality. The traffic used for synthetic transaction testing is artificial and not representative of real users' experience. As a result, it outcomes the performance are often predictable, and synthetic monitoring relies on simulated actions rather than real user behavior. Another drawback is the time-consuming nature of incident resolution. So when you receive complaints from the end users in real time, in the real time, synthetic monitoring data doesn't reveal what the users was actually doing or experiencing. So to identify issues, you would need to analyze the performance for every critical transaction and create a scripts for synthetic testing. So which can be a quite time consuming as well. So lastly, synthetic monitoring offers a narrow view of performance. It cannot capture the rich diversity and performance variables so present in the real world usage because it does not monitor actual users. So consequently, you will only receive a limited perspective on the application's performance. So how the real user monitoring works in the applications manager to facilitate data collecting and reporting. The RUM agent is deployed on the server where the application is hosted. So this real user monitoring is also agent-based monitoring. And the small JavaScript snippet generated by the applications manager need to be placed in the header or footer section of the HTML code in the application. So once the JavaScript snippet is loaded in the front end page of your application, so it acts as the core component that collects performance data and continuously transmits to the RUM agent. Then the RUM agent will communicate between the JavaScript code and the applications manager web client, describing the captured data for analysis. So based on the data, we can identify the performance hiccups. So real user monitoring in applications manager helps you to analyze front-end performance across various geographies, internet services providers, browsers and devices. So which will allow you to proactively access how these factors impact website performance and ensure a smooth digital experience. Also, you can measure end user satisfaction, identify poorly performing web transactions, and understand user satisfaction levels through AppDex scores. Additionally, you can gain comprehensive insights into domain sources and user sessions very quickly, and further, you can quickly identify errors and evaluate the impacts of new changes. And lastly, it will help you to detect JavaScript errors, prevent users from experiencing service issues, and analyze how recent changes affect the overall user experience. Now that we have covered both real user monitoring and synthetic transaction monitoring, let's discuss how they complement each other and provide significant benefit for your website. First, let's talk about correlating business with performance and synthetic transaction. Well, here, synthetic transaction monitoring offers performance data that helps to identify issues like slow page load times, and network bottlenecks. However, to understand the web performance affects business revenue, you need more than just synthetic performance monitoring metrics. So here, real user monitoring provides a crucial insight into the actual business metrics, such as conversation rates, which can be correlated within the ongoing performance data collected by the synthetic testing. And this correlation helps in assessing how performance impacts revenue. So next, consider identifying issues before users encounter them. So problems are inevitable. So regardless of where your application is hosted, so the synthetic transaction monitoring is highly effective in spotting configuration issues caused by off hours maintenance or other changes. So which will allow you to address these performance issues before the user begin to access your application or website. So RAM, which is a real user monitoring, is the most valuable for measuring application responsiveness for each live user during peak hours. So when it comes to the troubleshooting outages, combining synthetic and real user monitoring data can be incredibly helpful. If a synthetic test fails or triggers an alert, a RUM data will show the real-time impacts on user experience. Similarly, if RUM data reveals a performance anomaly, you can use the synthetic testing to replicate the issue across your internet services providers and geographical locations. So this approach allows you to gather data from multiple vantage points and pinpoint the root cause. So which may be in the data path between the end users and your application service. Also, I would like to inform you that the synthetic transaction monitoring RBM, real user monitoring RUM, and the APM Insight feature or comes under the add-on modules. So where you need to purchase a separate add-on, and the number of monitors will be counted from the existing licensed monitors. So now let me take you to the App Manager UI and show you the working behavior of APM Insight, real browser monitoring, and real user monitoring. Hope the application manager UI is visible, and this is how the applications manager UI looks like. And let's start with the APM Insight Monitor. So under the Add Monitor page, we can have the complete section of the supported monitors categorized on the left side. So in the APM Insight, as we discussed, so these are all the supported application performance monitoring modules. Let's take, we are going to add a Java APM Insight Monitor. So here we have a few prerequisites, and the light side we have the supported for platform. As I mentioned in the presentation, so we have simplified the user experience in order to add the APM Insight monitors seamlessly. So first we need to choose the deployment type, whether your deployment is on the container or the host. So after choosing that, we can choose the operating system, whether it's a Unix or a Linux. So let's say we are going to deploy a Tomcat Apache Tomcat application server. So I'm choosing this, And the next step is going to be the application name and the Java version and the other settings. In the advanced settings, we can have the complete host details. Proceeding to that, here's a simple step. So after executing a few commands, the complete agent will be deployed and the monitor will be added. So in order to give you a better user experience, I have hosted a sample website, a web application. So this is a JPEG store, which is a sample web application. So I have hosted in my own server and I have added it for monitoring. So let's do some transactions. I'm clicking on the fish and getting into a specific fish and adding it to the cart. So once after this application, once after you deployed the agent and added it as a monitor, it will be available under the APM tab. So this is the application that I hosted, which is this application, and currently it is under the monitoring. So here under the overview tab, I can have the complete golden metrics as we discussed for the last 30 minutes. Currently the APDEX score is 100, which is satisfied, and the current average response time is around 6.7 millisecond. And the request overall in the last 30 minutes, I have made around 29 requests and 0.97 requests per minute. And currently there is no data came in, and currently 5.70 kb data that went out. There is no exceptions or fatal errors occurred. And if I go scroll down even more, I can have the complete overview of the details, and these are the top 5 transactions by the response time. So let's say you have a production web application like a banking website or e-commerce website. So there could be multiple transactions that can occur. There could be a million transactions. So as application owner, we need to make sure all the transactions are made clear for the end users. So we are if we monitor all the transactions, it could be a tedious task. So here, in order to simplify this even better, we have the top 5 transactions by the response time. So in this top 5 transaction, what are the top 5 transactions that is taking more response time? So we can directly drill down into the transaction. So I can show you in this specific demo page, as this application is a sample one. So you can still access this demo page from your application, from your host as well. So this, for this Java application, if I scroll down even more, I can have this specific transaction. So host resource is a specific transaction that is taken more response time, which is 76 seconds. 70 seconds is a more hard time, right? So I just want to drill down into the resource, so which is causing this specific application a more time. So these are all the time frames that is taken more response time. So these are all the response time broken by components. By hovering to the spikes, I can see the app code execution has taken more time, and compared to the PG SQL, the database that is associated, and the overall response time. So likewise, I can have the complete details over here. So if I want to drill down into the any specific trace, I can get into the specific trace. So this specific trace is taken around 139 seconds as the average time. So here I have the complete trace details, which is the stack traces, I would say. So here I have the complete. So totally, in order to complete this specific transaction, it is taking around 10 method calls and 102 SQL calls. So here we can find this specific transaction is having the high transaction time. So I can share this information by taking a screenshot within my internal team. So once after this, we can have the SQL statements. So in this SQL statement, here we have seen 1 or 2 SQL statements were made. So we can have complete SQL statements that was executed during the transaction, and here we can sort out using the rows affected. So we can share this specific detail in order to optimize the application with our internal team. Same like what are the PG calls that was made, and what is the execution time, and which queries have the high execution time. We can identify all the traces, and it happens. And in the other transaction, other traces of the transaction, we can have the complete transaction response time throughput. So this is a summary, and from the transaction tab we are going to the traces tab. So next one is the database tab. So here we have the complete select, update, insert, delete queries that are ongoing executed in the backend of your application. In this database operations, if we want to just sort out by the average response time, so we can identify, okay, compared to other queries, this specific query is taken more time. So likewise, we can identify the specific queries. So likewise, we can have the exceptions. If there are any exceptions, we can find those exceptions over there. So let's say this is the application we are currently having. So I'm just going to be make a exception. Okay, currently it hits a 404 error. So here in this exceptions tab, so after some time, we can have that specific 404 error in a while. So this is how it looks like. So if you get into this, so what are all the transaction? This is a failed transaction, and this transaction. So we can have this specific transaction name, and we can drill down into the time and period when this specific transaction was occurred. So this is how we can continuously monitor our real-time performance of your application performance. And in the service map, as we discussed, we can have the what are all the external resources that has been associated with your APM Insight Monitor. We can have a complete look by hovering to the specific instances. We can see the health details of them. And by default, we have the app parameters. We have the JMX parameters by default. If you have any other app parameters, you can manually add them. So that profile is nothing but you can create it on demand. But clicking on the collection time, we can have the current threads and what are the stack traces that is taking more CPU time or getting the block threads. We can share this information with our internal team for optimization. And rum analytics is something I just we mentioned and we brought this in the recent times. We can have the complete front end performance like the APDEX score of the front end level, the average time page views, and the JavaScript errors as well. So this is for the APM Insight monitor. Let me quickly take you to the real browser monitor. So adding a real browser monitor is also a simple process. So let's say we have, I'm just copying this specific URL. I'm just getting into a new incognito window. So once after you deploy the agent, you need to install this web transaction. So here I'm going to log in using my host name and the port using a web server port and the API key. I'm just taking this API key from my applications manager under the settings, user management as the administrator user. I'm just clicking here, just copying this, pasting this API key and logging in. So once logged in, so we can copy the transaction, we can copy the website to do a transaction. So here I have copied. I'm just pasting over here and start the recording. So it will be loaded, the recording will be occurred. Now I'm making some transaction. I'm getting into the fish, adding the goldfish, the female fish add to cart, and now I'm getting into the dogs, getting into the bulldog and adding a male bulldog into a cart. So these are all the 4 5 transactions that I made. Now I'm going to stop the recording and save the monitor. So here it will ask the monitor name and the polling interval. As we discussed, Firefox will be the default browser which is bundled within the agent. And if you want to do the specific transaction using Edge or Chrome browser, so there are some prerequisites, simple prerequisites. So once after completing that, we can simulate the transaction using the other browsers as well. So if you want to associate with any other groups, we can associate it. And just want to have the screenshot show the performance metrics. And this is a one agent that is currently being added in applications manager. If we have deployed multiple agents in multiple geographies across, we can select that agent as well. So once we save the monitor, after the poll on the monitoring will be started. So once after the monitoring is started, we can see under the real browser monitoring. So I have already have the Store real browser monitoring. I'm just getting into the monitor. So we can have the complete performance details over here, the average page load time and the transaction time over here, and what are all the steps that was taken. So totally, so according to the steps, according to the time frame, we can see the complete performance. So totally 10 steps were made, and compared to these steps proceed step, the home page step is having the page load time, higher page load time. Currently all the paging are working as expected. So and these are all the screenshots, the transaction that we made. This is the first transaction, this is the second transaction, this is the third transaction, fourth transaction, fifth, sixth, seventh, eighth, ninth, and 10th. So these are the complete transactions that we made. and for each of the transaction we can have this beautiful pie chart showing the resource details, so how much the image that was consumed in this transaction, and how many html that was allocated, and what is the image size and the resource count in percentage as well. So here we have the beautiful water chart view, and in this water chart view we can have the complete front end performance. If any of the css or html that is taking more consumption, so we can work with our internal team to optimize the resource. This is how the real browser monitoring works. Same like real browser monitoring, we can have the real user monitoring. So in order to add a real user monitoring, once after we deployed the agent, we can get into the real browser monitoring. Here we can enter the website that we are going to monitor. Once after naming the website and getting those details, so just let's say we have a test pet. Okay, the url is going to be this, for example. I'm giving this url. I'm just naming as a local host. Going to the next, and we can choose the agent. So once after choosing the agent, for example, this agent. So once after choosing the agents, it will be added as a monitor. So once the monitor has been added, so it will be available like this. So currently I have set up this applications manager into a real user monitoring. So currently this what are the transactions that I made right now will be recorded in the front end level, and this is the script I'm speaking about. So we need to inject the script in the front end landing page of your application with the help of your application team. So once this script has been injected after the application restart, agent restart, the data collection will happen. So under the summary tab we can have the complete APDEX score. So based on the APDEX score is nothing but the response time that is taken. Based on the response time, this APDEX score is calculated. So previously we seen the APDEX score for the APM Insight, which is a complete overall real-time transaction using the backend level as well. So here on the front end level user experience, this APDEX score will be given. So currently 99 users are satisfied, and only zero point 0.3 is tolerating, and none of the users are frustrated for this application. So average response time is around 640 within this specific down frame, specific time frame. And how many in this specific time frame, these are all the pages that were viewed and what is the error counts. And in the geography map, this is something very cool. I will show you. We can differentiate into the different maps as well. So to have more clear data, maybe I can show you over here. So under the real user monitor demo page. Okay, so this geographical map. So see, this is a complete world map. And if I hover to any specific region, I can see from Russia, I can see the average response time is around 1000. If I hover to India, the average response time is around 3281. So compared to the India users, the Russia users are having more comfortable in accessing our application. So same like we can, differentiate and sort out using the similar country as well. In Australia, I can see the raspberry response time is around 400 milliseconds. So likewise, we can differentiate using the different geographies and internet service providers. So these internet service providers, we need to complete a simple prerequisite. So once the prerequisite is completed, we can have the complete details of the internet services providers. So here we can differentiate using what are all the internet services provided, how this was performed. For example, the WA VPN is one of the service provider, and VPN is one of the internet service provider. So users accessing your application using the WA VPN are having a good response time, and compared to the this specific internet services provider, those users are having a high response time. So which is quite uncomfortable in accessing your application. And the next one is the browser. And in the browser we have this good chart, and if you scroll down even more to have clarity, so four browsers are accessed within your application. So currently Chrome browser, Edge browser, Firefox, and Firefox iOS. So users are accessed within this browser, and here we can clearly see Chrome users are having high response time compared to the Firefox users having the low response time. So we can work on this internally, and in order to give a better better uh, user experience in the front end level. So these are the versions, and compared to, if you see, this specific version have the high response time compared to this specific version. Same likewise, we can enhance the performance of our users by optimizing our application. And device type is also plays a vital role. We can have the complete pie chart and the chart reports. And when it's come to the device tab, iOS users having the low response time compared to the Mac OS X, this specific OS users, and Windows users and the Ubuntu users. So here we can also check into the complete bar chart percentile detail and the throughput details. And what are all the web pages? So in the APM Insight, we have seen the complete, web pages in the backend level. So here in the front end level, how the web pages are performing, we can have the complete granular details, which will help us to optimize the application. And under the user sessions tab, we can have the complete users that are currently accessing your application, and how many users are accessed and how many users are left the website, from which what is the user id, what is the name, and from which browser they accessed, and what is the device type they used, and from which country they access the website. So likewise, these are all the complete details we can have. For example, let's say user this specific user using a Chrome browser in a Windows device tab from China navigated 21 pages. Same like this specific user navigated around 21 pages from the Australia. Likewise, we can have the complete drill down details, and if we drill down even more, we can have the each transactions, DNS time, connection time, those details. So under the resources, we can have the first party and the third party resources that has been associated within your application, and what are all the response time that is taking in order to access those third party applications. And under the Ajax, if there are any Ajax call available, so we can see those Ajax calls as well, and the APDEX score of the each Ajax call. Apart from that, if the users found any JavaScript error in the front end level, so they can able to see those errors, and what are the files and what are all the pages that were attempted in order to get those JavaScript errors, we can have the complete overview detail. So these are all the two errors that were identified, and what is the type of error and what is a file. So this is specific server info were affected in the JavaScript error, and this is a specific page. And while accessing using the Firefox or iOS or the Chrome, this JavaScript error was identified, and these are all the two users that were attempted this specific error, and these are all the domain. So likewise, this complete overall details we can able to understand using the real user monitoring. And so this is how we can able to bring back the data using applications manager for APM Insight, real user monitoring, and the real user monitoring. Now we have discussed the complete details of the three details of the APM Insight, real browser, and real user. Let's have a quick recap on today's session. Started from tracking application performance using APDEX score and finding problems in the application code. Further, we discussed on the tracking transactions from one application to another, and debugging the issues, identifying problems in the code stack as well, and how service map makes it easier to identify the problems. Later, we looked at identifying user impacting issues through synthetic transaction monitoring, analyzing the user behavior patterns to gain the front end level performance using the real time user experience monitoring as well. Thank you for showing interest in attending this webinar. Have a nice day.